Hello community, I am Karan Kumar, and in this session I will be discussing about object-oriented programming in Dart, which serves as a foundation for Flutter development. Dart, which is the language behind Flutter, follows OOP principles, making code more structured, reusable, and scalable. Understanding these concepts is crucial for writing efficient and maintainable Flutter applications. In this session, I will cover basic fundamental of OOP, and by the end of the session, you will have a solid grasp of how OOP is applied in Dart and how it helps in building Flutter apps. So let's get started. So the first of all, we will discuss about Dart. So Dart is a modern programming language which is developed by Google. It is optimized for building fast and scalable applications. One of the Dart's key strengths is its strong typing and type inference, which helps developers write reliable and maintainable code. It also offers the best of both worlds when it comes to compilation. Just-in-time compilation for a fast development experience with hot reload and ahead of time compilation for optimized performance in production. Dart is also the primary language for Flutter. Its seamless integration with Flutter enables smooth animations, responsive UIs, and overall performance. With its simplicity, power, and flexibility, Dart is an excellent choice for modern app development. So, here comes an interesting fact. Dart syntax is inspired by languages like Java, JavaScript, and C Sharp, making it easy to learn for developers familiar with these languages. So, if you have any idea of Java, JavaScript, or C Sharp, then it's easy for you to learn Dart. Now coming to the object-oriented programming. So object-oriented programming is a programming paradigm that organizes code with the use of classes and objects. So object-oriented programming has four fundamental pillars. First one is encapsulation, then inheritance, then polymorphism, and then abstraction. And I will explain all of these pillars in the upcoming slides with examples. So here comes the most basic part of OOP, which are classes and objects. So class is basically a blueprint or template for creating objects, and an object is an instance of the class, right? So you can understand with the help of real world examples, like just like a card is an instance of a vehicle blueprint. Similarly, bike is also an instance of a vehicle blueprint, right? So that's how we can relate with the real world examples. Now I have demonstrated one code here. So in Dart, we use class keyword for creating classes. So here I've created a class named vehicle, and there are some properties inside it. So a model is a variable which is stored in Tesla, and there is a method called start. In in the classes, functions are basically known as methods. So that's why we are calling start as a method. Okay. So now in the main function, I have created an instance of that class and stored it in a variable mycar. Now I can access any of the property of this class with the help of mycar variable. So if I write mycar.start, so it will just invoke the start method of the class, and so it will print basically it will print Tesla is starting, right? And if we want to access this model variable, then we can write mycar.model, and yeah, it will print Tesla. If you want to update the model, then we can also write mycar.model equal to whatever we want. So it will update the variable also. So that's how we create classes and objects in Dart. Now here comes an interesting question. Uh, I want that you answer the output of this code. So first of all, pause the video, think the answer, and after that, resume it. Okay. So here I've created a class named vehicle, and there is a variable called type uh, which stored car. Okay, and in the main function, I have created an instance of a class vehicle, and I'm updating the type variable of that instance to bike. So vehicle type equal to bike. Okay. Now in the next line, again I'm creating an instance of a class and printing its type variable. So print vehicle dot type is printing the type variable of that vehicle instance. Okay. So the correct answer of this code will be car, because in the first line of the main function, I am creating an instance of a class. Okay, but I am not storing it in any variable. Okay, so now when I come to the next line, then this instance of the class that I created in the first line is destroyed from the memory. And in the next line, when I'm creating a new instance of a class, it's completely new instance and not dependent on the previous instance, because the previous instance is already deleted from the memory. So in the second line, I'm creating a new instance of a class, but its values will be car only, now because it's new instance, it's not updated. So the correct output will be car. So yeah, this is an interesting question. This is an interesting concept, and yeah. and I hope you have answered correctly. So now coming to the constructors. Constructions, a constructor is a special method in the class that is automatically invoked when an object is created. Basically, it helps us to initialize object properties. Suppose we want to set the variable of this type according to the argument that we provide. For this reason, constructors are used. Constructors are basically whatever you write in the constructors that will be automatically invoked when you create the instance of the class. Correct? So whenever you create any instance of the class, constructor function will automatically be invoked. So here I have shown one demonstration. So I've created a class named vehicle, and there is a variable called type. And here I have called the constructor vehicle. So one important thing is that the name of the constructor should be same as the name of the class. If it will not same, then it will give error. Okay. So in the argument of this vehicle function, I have written this dot type. So basically, it's a short form of signing the value to the type according to the argument. Okay. Now I have created a method called display and it's printing vehicle type. Now in the main function, I have created an instance of a class vehicle and I'm passing car as an argument. So I am creating instance of a class. So the constructor will be automatically called and it stored that the value of type to car. Okay, card in the value, card in the type variable. Okay, so when I call v1 dot display, so I am calling the display method, then it will print vehicle type to car. Basically, the output of this code will be vehicle type car. Okay, I hope you have understood constructors. So now coming to the first pillar of OOP, which is encapsulation. Encapsulation is about bundling data and methods that operate on that data into a single unit. Basically, encapsulation is the concept of hiding data and restricting direct access to it. It helps in maintaining data integrity and prevents unintended modification. In Dart, we achieve encapsulation by using private variables and providing getter and setter methods for the controlled access. So here I have shown an diagram showing how methods and variable are encapsulated in a class. Uh, we For private members we use underscore. Okay, so basically for any private variable, the variable name starts with underscore in Dart. Uh, you can compare it with the real world examples like encapsulation is like the dashboard of a car, hiding the complex engine but giving you the control. Now there are two type of variables in classes: public and private variables. The public variables are those variables that can be accessed anywhere from the program. Okay, it can be accessed from inside the file or outside the file. Okay, by default, all the methods and variables are public by default. Private variables are those variables that can be accessed only within the file, but you can't access from outside the file. Uh, all the private variables, all the names of the private variables start with an underscore. So that's how we distinguish between public and private variable. If the variable name starts with underscore, then it's a private variable. Here I have shown a coding demonstration. Like I've created a class in vehicle, and there are two variables, brand and model. Brand is a public variable because there is no underscore in the starting of the name, and model is a private member because there is a underscore in the starting of the variable name. And brand is stored in Tesla, and model is stored in Cybertruck. And there is a method called display, which is displaying brand name and model name. Now in the main function, I am creating an instance of a class vehicle and printing the brand and model value. Like currently, this code is written inside the file, so it will not give any error and simply print the model and brand name. Okay, but if the same thing I'm accessing from the outside the file, then it will give error. You can try from your own. Like you can create a class in one file and you can create an instance of that class in another file, and now you try to access the private member of that class. You will definitely get an error because you can't access a private member outside the file. You can access it from any side, anywhere inside the file. There is no problem. But if you try to access from outside the file, then it will simply give error. Now there are two important methods, which are getters and setters. Like if you want to retrieve or update the value of the private members, then we use getters and setters respectively. Getters and setters are important method for achieving this. So here I have demonstrated on code. I've created a class named vehicle, and there are two private members, model and year, and I am updating. And I'm using constructor for initializing the model and year. Before explaining the code, let me explain about this keyword. So basically, this is a keyword that refers to the current instance of a class. It helps when we need to access instance variable or methods from within the class. Okay. Now this is the syntax of the getter. So if you want to retrieve the value of the year, then you can use this syntax of getter. And if we want to update the value of the year, then we use this setter syntax like this. Here we can add any kind of validation or control access, whatever we want. You can add here, and according to this validation, it will update the value. Right now, here I have given the validation that if the year that provided as an argument is between 1900 is greater than 1900 and less than equal to current year, then and only it will update the year. Otherwise it will give an error and printing invalid year. It will not update it. Okay, so basically I have created a instance of a class and storing it in my car variable and initializing with Toyota and 2020 as model and year, and I'm printing the year. As the year is a private member, so I have to use getters. So as I have created a one getter here, that's why we are able to access the year variable of the mycar instance. If we are not using getters here, then we will not able to retrieve the value of the year because it's a private member. And this code I'm running outside the file. Okay, keep in mind, because if this code is inside the file, then there is no issue of creating getter, and then there is no use of creating getter and setter. It can be automatically retrieved or updated. Okay, and now I am updating the value of the year to 2025. So first of all, it will check the validation, and if it's qualified the validation, then it simply update the year value of the year variable, and simply printing the updated year. Okay, so you can see that there is no difference between the syntax of retrieving the data as in the normal way. We are using the same way as we did in the normal way, like mica.year equal to 2025 and all that. But for achieving this, we have to create one getter and setter in the class. If you are not able, if you are not creating that getter and setter in the class, then you can't access it from outside the file. Okay, so getters or setters are basically a method that is used for controlled access of the private members. Now coming to the second pillar of OOP, which is inheritance. So inheritance is a key OOP concept that allows the child class to inherit properties and behaviors from parent class. It promotes code reusability and helps in building hierarchical relationship between classes. So basically, its main purpose is code reusability. Suppose there is a class named vehicle, and car and motorcycle is uh, inheriting the property of the vehicle class. Like whatever property is mentioned in the vehicle class, that property can also be applicable to the car and motorcycle class because it's extending from the vehicle class. Okay, it's just like a family tree. Child classes inherit traits from the parent tree. Parent. You can relate with the real world examples. Okay. Now I have shown a demonstration of the inheritance. So I've created a parent class vehicle, and there is a variable in brand which stores Toyota, and there is a method which prints the brand is starting. Basically, Toyota is starting. It will print Toyota is starting when we uh, call this function. Now I'm creating a child class which is inheriting from this parent class vehicle. So the keyword that we use for inheritance is extends. So class car extends vehicle. So it's extending vehicle property. So whatever property is mentioned in the vehicle, that property should also be applicable for the car class. Okay, so brand and start is also applicable for car class because it's a child class of the vehicle. And there is a special variable here, wheels. So this wheel property is applicable for this for the car class only. Okay, I hope you have understood it. Now in the main function, I'm creating an instance of a car variable. Okay, and now I am calling the start and display method. You can see I haven't wrote start method in this car class, but it will print Toyota starting. Okay, because it's extending from the parent class. So start and brand is also available in the car class. Okay, so this is output of the code. So Toyota is starting, and the next line we will get brand Toyota and wheels 4. So now comes the third important pillar of OOP, which is polymorphism. The meaning of the word polymorphism is many forms. In simpler terms, polymorphism allows one function or method to have different behaviors based on the object that is calling it. This makes our code more flexible and scalable. So polymorphism allows objects to take on multiple forms. As here, I have demonstrated one code, like I have created a class named vehicle, and there is a start method in it, which is printing vehicle is starting. Now I have created another class bike, which is extending from the vehicle class. So basically, I am using inheritance here. Now in the bike class, I am overriding the start function that I have created in the vehicle class. So there is only one start method, and I am using it as a different form in the bike. So that's how polymorphism works. So I've overridden the start method of the vehicle class. Now in the main function, I have created an instance of a bike class and stored it in a variable called myBike. Now I have called the start method from this myBike variable. Okay, myBike object. So now the output of this code will be bike is starting with a kick because we have overridden the start method of the vehicle class. Okay, if we don't write override here, by default Dart has functionality that it override it. Okay, so in real life example, you can understand polymorphism like a vehicle that can transform into different modes, same interface but different behavior. Now comes an important keyword, which is implements. So implement keyword is used to enforce a contract between a class and an interface. Uh, it would be more uh, helpful if you understand it with the code. Like I have created a class in vehicle, so I'm using vehicle class everywhere in order to maintain consistency. So in the vehicle class, there is a method called start, which print vehicle is starting. Now I have created another class car, which is implementing vehicle class. If I implement any class, then all the methods that is written on the parent class must be overridden in that class only. Okay, as in the example, I've created a class named car and implementing vehicle class. So all the methods which are defined in the vehicle class must be overridden in the car class. Like there is only one method. Currently, there is only one method in the vehicle class. So it is overriding only one method, which is start. If it has more than one method, then it has to implement all the methods that is defined in the vehicle class. If it fails to define in the class, then it will give an error. Like there is only now here is only one start method, so it's overriding start method, like right, which is printing card is starting. But in the right side of the code, again I have created a class named vehicle. But here again and also here again also I'm implementing vehicle class in the car class. But I haven't overridden the method of the vehicle class in this code. So now if I try to run this code, then it will give the error. So the rightmost code will give the error, but the leftmost code will not give the error. It will work finely. So basically, a class that implements an interface must provide concrete implementation for all the methods and properties defined in the interface. Unlike extends, which supports inheritance, implements is used for strict adherence to an interface. So it's different from extends. In extends, we don't need to override all the methods of the parent class, right? But in the implements, we have to override all the methods of the parent class. If we don't override it, then it will give a error. Now coming to the last pillar of the OOP, which is abstraction. Abstraction hides complex implementation detail and exposes only essential features. We can in Dart we have abstract the keyword for defining abstract classes. Like I have created an abstract class vehicle, and uh, the method which has no implementation is automatically defined as abstract methods. Like start has no implementation, so it's an abstract method. But stop is not an abstract method. Stop is just simply a method which has implementation like it's printing vehicle is stopping. Now I created a class named car and extending the vehicle class. So all the abstract method must be overridden in the car class because a vehicle is an abstract class and there is abstract method in it. So we have to override all the abstract methods. Like here is only one abstract method, so it has to override the start method. So I am overridden uh, the start method, like sprinting car is starting. So that's how abstraction works in Dart. There is one important keyword which is static members. Static members belong to the class itself, not to instances. Basically, if basically static members are those members which can be invoked without creating an instance of the class. Okay, can be accessed without creating an object of the class. It can be directly accessed from the class name. Like in the example shown here, I've created a class name vehicle and there is a static variable total vehicles which is 0, and there is a constructor which simply increment the count of total vehicles, and there is a static method show total vehicles which is printing total vehicle count, basically total vehicle and total vehicle variable. Okay, now in the main function I've created two instances of the vehicle class and stored it in a object variable, basically v1 and v2. Now as show total vehicles is a static method, so I don't need to create any instance of the class for calling that method. I simply create, I simply invoke the function without creating instance of the class. Like I have just used vehicle name dot show total vehicles for accessing this static method. So in order to access static method, we don't need to create any instance of class. We can directly invoke it from the from the class name itself. Now I want you to answer the output of this code. Like what will the count of the total vehicles here? Okay, think it and answer in the comment section. So we have covered all the four pillars of OOP. Now we will understand what is the importance of OOP in Flutter development. All the Flutter widgets that you see are built using Dart's OOP principle. Example, stateless widgets and stateful widgets are classes. You can explore more about this in the Flutter development. Like if you start developing any Flutter code, you can experience all the classes that is extending or whatever. You can explore uh, from there only. Okay. Here I have just shown a piece of code, like it's a stateless widget. Like there is a class my app which is extending from the stateless widget. So here I am using so here it uses inheritance concept of OOP, and you can also see that it's overriding some methods like that. Okay, so you can explore more about in the Flutter development. Now the what are the benefits of OOP? So OOPS has many benefits. The four major benefits are modularity. It breaks down complex apps into smaller and usable components. Maintainability. It gives us easier to update and debug code. Scalability. It's for building large apps with clean architecture. And usability, like we have understood inheritance concept, which helps in usability of code, which can be shared across different platforms. Now, the best way to learn anything is by doing. So I have understood you the all the basic concept of hoop. Now, in order to get the feel of it, you have to learn it by doing yourself. So uh, after watching this session, go to the documentation and practice some code in order to get familiar with it. And thank you for this, sir. I hope you have learned something new in this series. And thank you.